The shorthand for setQSelf to make object wing is simply make self wing. So over here we could say make self wing, and we have an instance of a wing. That one is also automatically set to our self now. So the old value of self is gone. We have this value of self, and now we can ask again for the taper, for example. Once we have a definition in memory, we can visualize using a web-based tool called Tasty. So to open Tasty, and go to our local host, if you're running your browser on the same host as you're running your Gendel session, :9000, that's the default port where Gendel is usually running, and then ask for Tasty. This gives a very simple first level form where we can type wing. So now we have an instance of the wing in this web-based environment. There are no graphics associated with this wing, but we can inspect some of the values here in the inspector. And notice that they're unbound until I click on them. That's the nature of Gendel being a demand-driven system. So in Tasty we have a tree, an inspector, and a viewport. You can normally expand and contract the tree. You can perform operations on objects in the tree based on a mode that you select under the tree menu, and you can inspect things in the inspector. One of the operations you can perform on tree objects is to draw their geometry. We will see more of these components when we get into an object that has some geometry in it. One operation you can do in Tasty is so-called break or set self to a particular object. Click on this break icon, then we click on this wing here. Now, if we ask for self over here, it's a new instance. It's the same wing which is showing up in this tree, and we can work on it here directly on the command line and ask it for its taper, for example. Now, input slots are the second main category. With input slots, you can give values to certain slots at the time of the object's birth. So in this UML diagram, we've promoted B to be an input slot. And in Gendel code, it would look like this. Input slots are in a separate section, and we have a list. In this case, it's a list with a single symbol that specifies a single required input slot. And let's go ahead and compile this code and now see how do we make an instance of a wing with a value for that input slot. So at the command line, we can now try and make self on wing with input. And that gives us an instance of wing with input. If we ask for the S, now we get an error. And if you look at the error, you see the explanation right at the top is this wing, which is the root object, that means it's the top of your tree, could not handle the B message. So because we asked for the S, and because the S depends on the B, and we did not provide a value for that required input slot, we now have this message. So our possible restarts are we can retry, we can abort, or we can abort. Press A for abort, which is a somewhat harsh way of describing simply exiting the debugger and putting yourself in the position to try again. In order to try again, we can provide the value for this input with a keyword argument to the make self. A keyword symbol is a symbol that you put a colon at the beginning. That makes it into a keyword symbol. A keyword argument consists of the keyword symbol, which acts as the name for the argument, and then a value, let's say 3. Now we can ask for the S, and we get an answer. Likewise, we could ask for the B to convince ourselves that our value of 3 made it into the object as B. So to review, the make self accepts the optional keyword arguments. And we did the example of passing in the keyword argument B with a value. So in this case, we use the value 3, we could use the value 12. Then we get a different result for the S. Now later on, you'll see we pass inputs into child objects. It's more declarative, but it uses the same syntax, keyword value pair, to pass values into child objects.